Hi, and welcome to another video in this Burst Education series. In this video, we're going to look at types of data, and identifying data types is important because the output of any study or research project tends to be data of some description. One important difference to consider here is the difference between data and variables. Generally speaking, the term data in a research and statistical context tends to mean the output or the results from a study, and they're fixed quantities. Variables, on the other hand, are obviously variable, which is to say they can take a number of different values. When performing an experimental study, we're concerned with two main types of variables. The independent variable, which can be experimentally manipulated, such as the dose of a drug, for example, and the dependent variable, which is the variable we hypothesize will alter as a consequence of our manipulation of the independent variable. For example, the improvement in quality of life. Other variables include things like control variables, which are variables that can influence the dependent variable, but they are identified beforehand and held constant during the experiment. Confounding variables, on the other hand, may also influence the dependent variable, but they are not taken into account beforehand, and so they may have a hidden influence during our experiment. So as we can see in this graphic here, the dependent variable can be influenced by the independent variable or control variables or confounding variables. We can take measurements of both the independent variable and the dependent variable, and each of these will give us a data point for each participant. And moreover, we can have a number of independent variables or dependent variables in the course of a study. We then have to analyze the data output to draw conclusions about the true effect of the independent variable on the dependent variable, while factoring in other variables. And this is the basis of hypothesis testing, which we'll come to in a later video. Now, if we look at a quick example to illustrate, and you'll have to forgive my drawing skills here, but if we want to do an experiment here on the effect of light on the rate of growth of a plant, our independent variable would be the intensity of light, which we could grade from no light to moderate light to full sunlight. Our dependent variable would be the rate of growth of the plant, which we would mark on some scale, for example, centimeters per day. Now, obviously, common sense dictates that sunlight is not the only factor which controls the rate of growth of plants, so you would have to factor in things like soil type, water levels, the type of plant, etc. And these would all be our control variables. There might also be other factors which we haven't considered and which we only think about after we finish our experiment. So those would be our confounding variables, which we don't know about yet. So as you can see, we might do an experiment using, say, 10 or 50 or even 100 different plants, use different light levels for each of those plants, and measure the rate of growth per day. So we would get a number of different data points for the independent variable, the dependent variable, and possibly control variables for each different plant. So depending on the number of plants we use for 1, 2, 3 independent variables, 1 dependent variable, and 3 or 4 control variables, we might get dozens or even hundreds of data points in a single experiment. So let's move on to the types of data we might come across in an experimental study. Data can broadly be divided into numerical data or categorical data. Numerical data, as the name suggests, means that the variable takes a numerical form or an integer. Categorical data means that the variable has some descriptive purpose, and we'll look at some examples in a little while. Numerical data can be further subdivided into continuous or discrete data. Continuous simply means that the data can take any theoretical value within a given range, whereas discrete data means that the variable can only take a certain fixed quantity from within a set of values. Categorical data, on the other hand, can be subdivided into nominal versus ordinal data. Nominal data means that the order of the data does not matter, but ordinal data is data in which the order is important. So let's look at some examples. An example of continuous numerical data is blood pressure, height, weight, age, all numerical values which can theoretically take any value within a given range up to any number of decimal places, although of course decimals are very rarely used. Discrete data, on the other hand, can only take the form of whole integers. Nominal categorical data, on the other hand, includes data such as blood group, which for the ABO system includes broadly 4 categories, and you cannot have any other. Gender as well is an example of nominal categorical data, where the order doesn't matter, but there are different types. Ordinal categorical data, however, is data in which the order makes a big difference. For example, the Gleason score. A lower Gleason score means something different from a higher Gleason score, and the order makes a big difference. Now, quantitative data can be converted to categorical data. For example, if you use blood pressure as a variable, you can define hypertension as a diastolic blood pressure of more than 90 millimeters of mercury and therefore convert a quantitative data point into a binary nominal variable, hypertensive or not hypertensive. But why would you want to do that? And the reason is because sometimes it's easier to summarize categorical variables, and this may help in your interpretation of your results and also for clinical decision making. Having said that, categorization significantly reduces the amount of information available because you're reducing the amount of data being used. And statistical tests will always be more sensitive the more data you have, which is to say it will always be more powerful for continuous data. So broadly speaking, continuous data are usually better for statistical tests, but categorical data might be better for summarizing results. And which one you use will depend on your hypothesis and the aims of your study. I'm not going to go into any more detail now, just to keep things light, but do check back for further videos in the series on hypothesis testing and statistical tests, where we'll talk about these concepts in more detail and build on what we've already learned. See you soon.